Welcome to my project bazaar.com. Let me discuss about the project Multimedia Information Retrieval based on late semantic fusion approaches, experiments on a Wikipedia image collection. Let me discuss about the abstract of the project. Content-based image retrieval is the application of computer vision techniques to the image retrieval problem. That is, the problem of searching for digital images in large databases. Content-based means that the search analyzes the contents of the image rather than the metadata such as keywords, tags, or descriptors associated with the image. The term content in this context might refer to colors, shapes, textures, or any other information that can be derived from the image itself. CBR is desirable because searches that rely purely on metadata are dependent on annotation quality and completeness. Having humans manually annotate images by entering keywords or metadata in a large database can be time consuming or not capture the keywords desired to describe the image. The evaluation of the effectiveness of keyword image search is subjective and has not been well defined. In the same regard, CBIR systems have similar challenges in defining successes. In this project, retrieval images are carried out by certain feature extraction methods such as color feature extraction, texture feature extraction, and shape feature extraction has been performed. The evaluation of effectiveness of keyword image search is subjective and has not been well defined. Initially, the text-based information is fused with images by non-sampled count and transform. In color feature extraction, color histogram, color moments, and color autocorrelogram have been proposed. For texture feature extraction, cable wavelet and Haar wavelet process have been implemented. Finally, for shape feature extraction, Fourier descriptor circulative features have been proposed. The extracted features are then optimized by co-occurrence matrix. Features were optimized and approximated to relevant features. These features are finally classified with similarity computation equivalent distance so as to can retrieve the relevant images from the database. Let me discuss about the flow diagram for our process. First, take the query image from the dataset folder or else type the text which is relevant to the query image. In the pre-process step, generally medical images are noisy. The noises in the images reduces the quality of the images. In order to improve the quality of the images, we normally employ some filtering operations. Median filter is used for filtering. The median filter considers each pixel in the image in turn and looks at its nearby neighbors to decide whether or not it is representative of its surroundings. Instead of simply replacing the pixel value with the median of neighboring pixel values. Next feature extraction has been proposed. Here three features are extracted: color, texture, and shape. In the color feature extraction, color histogram are estimated. The color histograms for color feature and wavelet representation for texture and location information of an image. This reduces the processing time for retrieval of an image with more promising representatives. The extraction of color features from digital images depends on understanding the theory of color and the representation of color in digital images. Color spaces are an important component for relating color to its representation in digital form. Transformation between different color spaces and the quantization of color information are primary determinants of a given feature extraction method. The color histogram feature has been used by many researchers for image retrieval. A color histogram is a vector where each element represents the number of pixels falling in a bin of an image. Next, in the color moments, a color retrieval method based on primitives of color moments is proposed. After dividing an image into several blocks, the color moments of all blocks are extracted and clustered into several classes based on fast non-iterative clustering algorithm. The mean vector of each class is considered as a primitive of the image and all primitives are used as a feature vectors. Next, in the color correlogram. Color correlogram is neither an image partitioning method nor a histogram refinement method. Unlike purely local properties such as pixel position, gradient direction, or purely global properties such as color distribution, correlograms take into account the local color spatial correlation as well as global distribution of this spatial correlation. While any scheme that is based on purely local properties is likely to be sensitive to large appearance changes, the correlograms are more stable to these changes. Such an image feature turns out to be robust in tolerating large changes in appearance of the same scene caused by changes in viewing positions, changes in background scene, partial occlusion, camera zoom that causes radial changes in shape, etc. Next, in the texture feature extraction, here Gabor wavelet and Core wavelet are proposed. Gabor wavelet is a classic method for multi-channel, multi-resolution analysis that represent image variation at different angles or scales. A Gaussian modulated sinusoid by capturing image details at specific scales and specific orientation. Next, in the Hoare wavelet, Hoare wavelets are fastest to compute, the simplest to implement. In addition, user queries tend to have large content colored regions which are well represented by this basis. One drawback of Hoare basis for lossy compression is that it tends to produce blocky image artifacts for high compression rates. Next, in the shape feature extraction, here Fourier descriptors and circularity patterns are extracted. The Fourier, each image of the logo database is decomposed into its image components, that is its connected components, as an abstract representation of an image components. We use their Fourier descriptors which are made invariant against translation, scale, rotation and their starting point. Next, in the circularity descriptors, the first two level of features derives a simple object description that includes the object size, the circularity of the border and the position of the image for first 5 objects. Next, in the optimization technique, we used co-occurrence matrix. Co-occurrence matrix or a co-occurrence distribution is a matrix or distribution that is defined over an image to be the distribution of offspring values at a given offset. Next, in the classification stage, equivalent distance are proposed which combine the calculation the distance between the query image and also the entire dataset images. The equivalent distance or equivalent metric is the ordinary distance between 2 points in equivalent space. With the distance, equivalent distance becomes a metric space. The associated norm is called the equivalent norm. Older literature refers to the metric of Pythagorean metric. Distance between points P and Q length is the line segment connecting them. Here databases images are fused with the relevant query image text and also the query images. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click the file and run for executing this process. This is the main window for the optimized retrieval of image based on content based and text based. Here select any one content information, that is if you select the content then you need to browse the query image from the dataset folder. If you select the text then you need to enter the query text. Here I want to retrieve the elephant images from the dataset folder, so that here I type the text as elephant. Here you need to select cover images, any one cover images. Here I display the cover image in the X1 plot. By pressing the pre-process button we can pre-process our cover images. Here I display the pre-processed image result of the cover images in the Access 2 plot. By pressing the feature extraction button we can move on to the feature extraction window. Here by pressing the color histogram, here we can estimate the histogram representation for each color, and by pressing the color moments we can perform the color moment picture. This is the blue region, this is green region and this is the red region of our images. This is the color moment picture values. By pressing the color correlogram we can estimate the color correlogram feature values, and by pressing the Gabor wavelet we can perform the Gabor wavelet function. This is the real and imaginary part of the Gabor filter, and here Gabor wavelet features values are displayed. By pressing the Hoare wavelet we can perform the Hoare wavelet transformation. This is the representation for Hoare wavelet feature, and here I display the Hoare wavelet with the help of in the Boolean displayation, and by pressing the Fourier descriptor we can perform the Fourier descriptor values, and this is the Fourier descriptor features, and by pressing the circularity features we can perform the circularity features. This is the peak value representation of circularity features, and here I display the feature values for circularity features. And now this is by the pressing the optimization button we can perform the optimized values for our features with the help of co-occurrence matrix. And here I finished the optimization process. By pressing the classification button we can perform the equivalent distance operation. Here all relevant images are retrieved from the dataset folder, and this is the query text, that is elephant image, and here this is the representation of precision and recall graph. Here I display the precision and recall value. General visual features most widely used in content-based image retrieval are color, wavelet, shape, and spatial information. Finally, the relevant image from databases has been retrieved. Thank you.